Welcome back to the show, team. My name's Amelia, and today we have yet another awesome guest on the show. They come out of nowhere. They're just wonderful. So, welcome to the show, Mars.
Thanks for having me.
It's an absolute pleasure. I'm not going to even attempt to tell everyone what you do. I really think that needs to be up to you. What is your job?
Oh gosh, I have so many. So I'm Tasmanian, and it's maybe a fantastically Tasmanian thing to have lots and lots of jobs, to be a very generalist freelancer. I am mostly in technology, and I come from a background of computer science, particularly machine learning. And in the last few years, as I've worked through academia, I've branched more into the science support and what's called instrumentation. So right now I'm doing a PhD at the University of Tasmania and CSIRO, where I work with large radio telescopes to try to adapt them for some tasks that they weren't made for. So in particular, we have a lot of really powerful radio telescopes built for astronomy in Australia, and also a thing called geodesy, which is where we use radio telescopes to look at stable objects in deep space to learn about how plates on the Earth are moving and update our reference Earth model, which is really interesting. And those are really powerful instruments, and we already have them. And so while we're looking at other problems that are really bottlenecked by our ability to build these powerful sensors really quickly and cheaply, we're looking more towards how we can adapt sensors we already have. Some of those problems are like space junk. We need to be able to track space junk and satellites to know where they are so they don't hit each other. We also need large instruments like that for things like SETI, the Search for Extraterrestrial Intelligence. So if we can look at these telescopes we already have, and we can add software components or hardware components that let them do more work than they were designed for, then all of a sudden we don't have to build new sensors. We can use what we already have. That's a really fun PhD. And on the side of that, I have a few jobs where I work with other places that are doing similar adaptation of sensors or building radar systems for space tracking. And I'm also a general technologist freelancer where I am an app developer, or I make websites for people who want to make educational games or interactive curriculum materials. And I've gotten more into the STEM educational materials space as well, which I find really fun. It's a nice foray away from my day job to go and get to do something really creative or for kids every so often. I really like that. I have a good mix of things. So that doesn't really lend itself very well to a single role or a title, but that is all of my jobs.
That was a lot of things all at once. They all sound awesome.
Thank you.
Actually, I've got a really mean question. Do you have a favorite one?
Oh, yes. So you might not know this, because any person who works alongside me in my office, or who I have coffee with or anything, has heard me say it 1,000 times, but my dream is to semi-retire in a few years and work remotely doing my tech jobs, which luckily in the tech space we can kind of work from anywhere there's internet, and move to the west coast of Tasmania and build my own planetarium, which is why I've concentrated more on this STEM and science communication skills in the last few years, because I want to be able to build simulations and dioramas and models and spend my days in between going and sitting in a corner and being an app developer on the internet, and then during the day running a not-for-profit planetarium and science center. So
Oh,
all
that
of my
sounds
educational materials jobs are my favorite.
that is so cool.
Thank you.
Okay, clearly watch this space. If there's anything we can do to help make that happen, that'd be really, really cool.
Just have to finish the PhD first, no big deal.
Yeah, no, that'll be a doddle. Now, all the way back before the really cool planetarium thing and the apps, etc., you mentioned Geodesy?
Geodesy, yes.
Geodesy. Can you talk a little bit more about that? Because you sort of skimmed over it and it sounded really, really cool.
Yeah, so coming from the computer science space, as I've started my PhD, just by the nature of the kind of theory I need to learn and the kind of instruments I need to work with, I found that even though I exist in the School of ICT, which is like a school of computing at the university I'm in, I've worked more and more with the people in physics, which just meant I naturally started being a part of and supporting and collaborating on projects with the people in physics who are in teams. Like, I work with the space weather people who monitor what the sun's doing and how much charged energy is coming off the sun that we need to look out for with our satellites, and that will impact the upper atmosphere and all the deep space stuff. And then geodesy, which I had never even heard of before I went there. Geodesy is this method where if we have two radio telescopes and we kind of know how far apart they are, what their relative like distance and angle is, and we use them to observe the same stable deep space object at the same time, say a black hole, and then observe how the relative delay of that observation hits each one differently over time, then that tells us when they're getting further apart or how their angular difference is changing. And we can do that with lots of telescopes all over the world to then understand how different tectonic plates are moving or about how different parts of the land is rising or sinking. And that is how we update what's called the International Reference Frame, which is our theoretical model of the Earth that we think of. You know, if you want to know what the altitude is at a particular point in the Earth, that's why we have those measures. That's why we know how much the plates move. And we use that reference frame for everything from like timing and positioning and a bunch of really important surveying methods as well. Geodesy.
And you say it seems quite obvious. It also sort of seems like something that would have been discovered by mistake.
No, we know that. So interferometry is a method that we've used multiple telescopes to kind of compare the readings from each. And that's been used for lots of things. It's based on the same theories as triangulation. Like if you have different, like when you see in a spy show when they're like, oh, can you track that person from their mobile phone call? And it's because there'll be cell towers near them. And if every tower near them pings the phone and then waits to get a response to say, oh, yes, we've heard it back, then different towers will take a different amount of time to get that response back because there is a static signal response time, the speed of light. That's how that works. And so if you know that it's taken a certain amount of time from a single position, that means you have a distance from there. You know the distance, but you don't know which direction. But if you get two of them, all of a sudden you know the distance from each of them, and that will only line up in two different places. And if you get three of them, then the distances from each will only line up in one. So with 3 points, you can identify a specific point in 3D space given only single point distances. Maths.
I do love like when maths gets applied to the real world. It's just so satisfying
Yes.
to be like, look, it's important, people. That's very cool, and I could probably get quite distracted, but obviously that's not your focus, so it's not fair to keep peppering you on
No, but that's
questions.
what my whole daily life is like. That's what my whole career has been like. I love technology, and I got into computer science because I love all the things that technology enables. And I think that sometimes people in computer science get caught up for computers for the sake of computers, and we do things like we reinvent the wheel over and over again, and we write papers about, look, we've made a machine learning model that's got an extra node than the last biggest one or something. But the most interesting technology in my mind is when it's applied to other fields. And I've made a career out of going around and listening to people much smarter than me talk about what they do, what their science is, and what kind of tools they would need to do it easier. And I try to make those tools.
I love it. Professional tool making enabler.
Yes.
Have you got any examples of using the sensors for something else, or how you actually would go about doing that? Like, do you look at a sensor and go, you could be used for these other things, if I sort of think about you creatively? Or do you like start off with a problem like, oh, we need to work out how to see space junk better or something, and then work like how do you solve those problems?
Well, we know that we have like the electromagnetic spectrum, and there are certain tasks that lend themselves well to different parts of that spectrum. So, like if you have a camera, you bought a photographic camera, and you can go around, you can use that to take selfies, but there are lots of things you can do with that. You might have it that it takes a single frame. Like if you take a video camera, you can kind of tell the depth of things based on how quickly things will move. And so there's like, if you get samples from a sensor over time, you can tell so much more information than the dimensions that they can see because of the relation between different things. And radio is kind of similar, that there are certain things that differences in the radio spectrum over time will tell you a lot more than examining visually. And the interesting thing about space junk is we almost need a combination of the two. If you have a photo and you've taken a 2D photograph of something, you can tell if you know which way the camera is facing, your position very well. You can take this snapshot and you can get a very good idea of the angle of something relative to you. But without a moving photo, it's very hard to tell the distance. you can tell depth from photographs because you can recognize objects in them and you know relatively what size they are. If I showed you a photograph of a completely unknown object, you would not inherently know what scale it is. It would confuse your brain. So optical, very good for angle, not good for distance. Radio has radar, which is very similar in theory to sonar, that travel and distance, travel and return time and distance, which means we get radio is really, really good for depth, but not for angle. And so if you use the two together, you can actually get a far better look. Unfortunately, optical looking at the sky. So Earth has the atmosphere, and like we know that if you look at the sky, you can't see through clouds. That bit's pretty intuitive. So optical suffers a lot based on atmospheric conditions like weather, like cloud cover. But actually the entire electromagnetic spectrum is really varied in how much it gets impacted by the atmosphere. And the radio part of the spectrum is actually the least impacted by the atmosphere. So like if you look at certain points of the infrared spectrum, a lot of it just gets absorbed by our upper atmosphere and you just can't see much through it, which is why most of our infrared space telescopes are out in space. So we don't have to look through the atmosphere. It's also why a lot of the UV spectrum doesn't get down to the ground, which is why we only get slightly sunburnt and we don't get irradiated and burnt to a crisp every time we go outside. Thanks, atmosphere.
We won't complain too hard about it then.
Yes.
Okay, so it's a bit of like understanding what those sensors can do and then also thinking about not just the sensor itself, but what you can get if you look at things combined using different sensors and then also over time and that like temporal value.
Absolutely. Yes.
Make it sound so easy. I'm sure it's easy to get like lots of telescope time to look at the thing you want, and that's not a problem at all.
No. Actually, that's actually the core of my job. Is not only do I adapt sensors to do things they weren't supposed to do, I adapt them to do multiple things at once. Because the more powerful the telescope, the more people want to use it, and the less likely you are to get dedicated time from it. If you go up to a powerful radio telescope that was built for astronomy and you knock on their door and you're like, hello, I would like to use your very expensive telescope to look at space junk, there will be like a whole foyer full of astronomers and astrophysicists who will be like, nah, we paid for this. Our science needs to get done. We need to unlock the mysteries of the universe. And you're like, okay. I will write a monitoring system that will just tap the incoming data where you're looking at deep space and doing your science, and I won't touch it once. I will make my systems observe that data and try to identify space junk in that. That's a process called commensal processing, which is a term from biology quite similar to symbiotic, but it's a one-way symbiosis. It's almost like a parasite, but that's not detrimental. So if you had a parasitic back-end processing system that was sucking duplicate data out and trying to make additional data products from that, that's commensal processing. So we don't step on the astronomers' toes because they will riot.
You don't need to worry too hard, listeners, about rioting astronomers. Well, it's possible though. You never know. That process you just described then would be the most delightful cartoon. I hope there's a cartoon of it somewhere. It's just fantastic.
Hoovering up data.
And it makes sense as well. Like you've got a punishing amount of data coming in. You may as well see if it can be repurposed and what else you can get out of it. Makes a lot of sense.
The thing about analog sensors is, like, especially a large radio telescope, it's basically taking voltage measurements, but like billions of times a second at different points along the spectrum. And that goes into a back-end processing system that extracts useful information by correcting for certain things. So like the Earth is going to rotate while the readings are being taken. You're getting readings from lots of different telescopes in different parts of the spectrum. And it basically flattens all that and you get a mathematical product out the other side. But all of that original data is just thrown away because the analog data is so large and it's so noisy, and we don't really, the data product produced by that back-end correlator is what the astronomers use. No one ever really thought we would need that first part. Right now, it literally goes into a black hole. We don't do anything with it. So until we start designing these commensal systems, we're collecting that enormous amount of data to distill into one tiny drop of information and then poured the rest back out.
It actually sounds a little bit, someone I spoke to a few episodes ago, she was looking at weather radar data before it had been manipulated so that you could see the rain. Yeah, correlated to the rain. And she was using it to look for waterbird migration.
Yes.
Because it's all still there.
Very similar.
It's just, yeah. It's it's kind of nice to know. I guess there's these lakes of data out there that could be tapped for other things.
Yeah.
You never know what you might find in there. It sort of sounds like you have no, it does sound like you have a lot going on. Do you have an average day that you could walk us through, or is there like
Oh God.
seasons to your work, or
Well, again, like in technology, we have less structure than many because you can work from anywhere. You can work anytime. You can often work by yourself. You're not as reliant on, I don't have to front up to a bench in a lab. And so I'm not beholden to business hours or business locations. But my typical day, everyone who's not Tasmanian is going to laugh at this and be like, oh, that's so quaint. I wake up in my tiny house, 32 square meters, that I live in with my husband. We live in like a little eco house. We walk to work and we have coffee in our favorite coffee shop, which is a hole in the wall in Hobart, with my two other office mates slash best friends. And we talk about what we're going to achieve on the day. Quite often, those discussions are running through bugs that we encountered the day before, and we, scribble on notes and talk through each other's problems. And a lot gets done over coffee. Actually, sometimes coffee will take 45 minutes, an hour. Then I go to work and I look at admin tasks. I am involved in a lot of small projects. Like I do a lot of outreach, and I go out and do like not university recruitment, but I'm in like unemployment programs, and I do tutoring, and I correspond with the media and all sorts. So every morning it's just like I front up to email hell for a bit, and I organize what meetings I have for the day. I have quite a lot of meetings. If I get blocks of time, then usually it's a combination of programming, because basically all my tasks are programming based. And on my desk, I have a sit stand desk, like all of us programmers trying to sit so much do have. And my entire desk is covered in these big notebooks that I have under my keyboard that I scribble things on. And because I work with some programming that's very close to the metal, very low level, they're all covered in like scribbled binary code and memory layouts and stuff. So my workspace looks like I'm a true psycho, because you'll show up and there'll just be like all these scribbles of ones and zeros and arrows everywhere of how I need to work out how this memory manipulation is going to work. Because high powered computing is just that. You need to think about the very low level memory layouts and how to get the most out of it. You need to think about where every bit is going. And that's very flow based. If I can get into the flow in programming, I'll do that. If I can't get into the flow and I've hit a wall with my scribbling all over diagrams and not solving problems or whatever, then usually I'll step away from programming for a bit and I work on system diagrams. I work on articles. Being an academic, I have to write papers. I have to submit to conferences. I have to write tutorials and blogs. Sometimes I scroll through Twitter because I try to engage with the other researchers as well. And I have a lot of people who I try to keep on the radar of if they run events. Like every year, National Science Week comes around. I'm involved in a lot of initiatives for National Science Week, and I have to keep an ear out for things like that. Well, they'll have events throughout the year. It's just kind of a mess. When you have lots of jobs, you have lots of tasks, and it's just every day you just like look at the stack, and whichever's the most on fire gets done first. And I have lunch, I work some more, I go home whenever I hit a break in my work, and unfortunately, very not nice to my husband, quite often I will walk home and he'll cook dinner and I will continue working. We'll hang out, watch Star Trek for a bit, and then he'll go to bed and I will stay up and continue working. Yes, he might crack it one day, but sometimes in these knowledge worker jobs, I love what I do and it makes me very happy. But at the same time, when you really like what you do and you have a very nebulous job structure, then it sometimes grows to consume everything. And so it's like twice a year, I realize that I'm really overloaded and I start cutting back for a bit, but that only lasts so long. So very, very messy, very messy. Ad hoc.
is there a system other than all the notebooks? I'm always curious how people everyone tries different systems, and I'm curious if you've got like a system that's working for you at the moment.
I use an app called Notion, which is like an internal wiki thing, which is really great because my husband and my workmates all use that. I've encouraged some of the people that I work with at UTAS, at my university, to use it as well. But all the normal systems that you're supposed to use, like we're all supposed to be very calendar driven, and I just cannot internalize calendars. in the way that I have now. Like, because I am a freelancer and I work for the university and I work with CSIRO, all of those things use different calendars, different email accounts that do not talk to each other. I have no one email app that I can open that will accurately show me what I have to do in a day. And that's why there is still so much that's just in my brain that I just have on notebooks and I have to remember. And everyone goes, yeah, you just need to like use these apps and make them talk to each other, and you use these bridges, and you accept that the minute you integrate anything that's Outlook based into anything else, then everything else will lose features, and that's just a fact of life. But no, actually, I actually think since COVID, I haven't had a good system, because it was just enough technological changes within each of those organizations in response to COVID. But they all still run off the assumption that if you work there, then that's the only place you work. So, of course, all the people who work at CSIRO, they just use the CSIRO ecosystem. That's fine. All the people who work at UTAS, same thing. If I was just freelancing, that would work. But all of them together, not very well. Post-it notes and scribbled notes. How bad for a computer scientist.
But very relatable. Yeah. Hopefully it comes down after the PhD.
Probably not. It's all about momentum. The more opportunities you accept, the more opportunities you create. And I love that. I mean, when I describe my day, it sounds hectic, but I love that it's hectic. I love that every day I work on different things. And I think that when I compare to some of the experiences I've had in interning, or like some of the experiences that some of my friends have working in tech, I think I have one of the most exciting tech jobs, because it is kind of a hot mess.
It actually sounds like the textbook hot mess.
Mm-hmm.
In all that, though, something you mentioned is, like with the high-powered computer work, is it's really important paying attention to where every bit goes. And that's kind of particularly interesting because I think it's easy for people to have a bit of a sampler of learning to code or whatever now, and it's getting closer to English language, a lot of the code. It's quite abstracted away from how the computer actually thinks. And it's kind of cool to hear that there's still people doing like the real code stuff.
Oh, I wouldn't say it's real code, but yeah, modern programming languages do hide a lot from you, and particularly if you don't know much about how programming languages work, then I mean, I know you do, but just in case anyone who's listening doesn't know much about how programming languages work, modern programming languages often work on a basis of intermediate languages. So they don't compile down into machine code, they compile down into an intermediate language, which compiles down to machine code. So it's almost like you're writing a programming language that compiles into a programming language that then compiles into instructions for the machine. But actually, that's one of the things that drove me towards radio telescopes. Like, obviously, space is friggin' awesome. But even aside from space, I think radio telescopes are cool because they're almost like this remnant, this old method of computing of like, it used to be that if you built a computer, it was this hyper specific machine. It was built to perform these calculations. It was built to fulfill this need or to do this task. And now we're in the era of what they call general computing, where you just have a PC and you can make it do anything. You can make it be, in medicine or in science or in accounting or whatever. You just install different apps and it does whatever. But in certain domains, that really domain specific technology still exists. Like if you build an MRI machine, it is an MRI machine. You're not going to install different apps and make it do different things. A radio telescope is built to be hyper specifically competent at what it does. It measures the EM spectrum in the radio range. It does that great. And so all of the back-end systems, the hardware components are domain specific. The languages, either they're not necessarily domain specific, but quite often they still run on Fortran. So they have their own vocabulary to speak about, and they have their own nuances that you need to learn about. And I really like that. I like that there are still sectors that have these very specific requirements that you can learn about and document and facilitate. It's the antithesis of what I really find chaotic about web programming, because like when you get in tech, so many people get into front end stuff, they do web, and I've always been crap at web. Like if you see my website, themartianlife.com, is handwritten HTML and CSS and SVGs that I've made by hand, and it will always be that, because that is all of the skills that I have for the web, and undergrad university, I did a unit on web and they made us write PHP 5, and it is the only programming language to ever make me cry because it fails silent. So the web is just this chaotic environment of like, you need to write one thing and people will try to run it on their smart friggin' toaster or on like this pocket book from 35 years ago and then complain if it doesn't work. It needs to run on everything and fulfill every need. It needs to work for everyone, and that's chaos to me. And I find a lot of safety in the opposite of like, there is exactly these operating environments, exactly these constraints, exactly this known set of users, and they need to interface with these known set of other systems. Do that well. And so when you can really know the environment and the constraints and the requirements, then you can make a really targeted solution. And I really like that. So high powered computing nowadays is moving into a more homogenous space because I guess consumer GPUs have become so cheap and so powerful that more and more of these previously hardware based, like the back end of a telescope used to be these things called FPGA components, where they're effectively hardware firmware combinations. They weren't software programming. And nowadays they're just pulling those out and replacing them with GPU boxes because they're cheap and they have great tech support. They got great tooling. They're easy and cheap to replace. And so that's much easier than having to keep around one guy who knows how those FPGAs work, just in case your telescope ever breaks. So we might be nearing the end of it, actually, in certain places, but I still think it's really cool.
I can definitely see the appeal. Definitely. The minute they brought out the folding touch phones, and
Oh
everyone was
yeah.
like, "Oh no, now we have to think about the thing," and everything got hard again. Different conversation though. I am very, very curious. What was your pathway from high school to where you are now? And like, what was the plan versus what's actually occurred?
Oh gosh, I was a horrible high school student. I was good at school in that I got good grades and I was well read and I loved particularly STEM subjects. I have Asperger's, which I think impacted a lot of how I interacted with the environment at school. So I was often really bullied and didn't deal with sensory stuff at work, not at work, at school very well. And in high school in particular, I wasn't doing very well. I ended up being sent to a smaller school, which was something that my parents did so that I would have a better time. But then also, when I had some stuff going on in my personal life, it was like everyone in the community knew, and that was really hard. So actually, through a confluence of events, I either got expelled or quit high school at the start of grade 11, depending on whether you ask me or my principal. He thinks he kicked me out. I think I told him to shove it. But I mean, in hindsight, it came out about 8 years later that this whole school in Queensland was basically a big embezzlement scheme and he wasn't really legit anyway. So maybe I was vindicated, but bad high school experience. And I went and I got a job in the import export sector, and I spent the next few years odd jobs, working at the circus, working as a silver service waitress, working in liquor and gaming, working in a bunch of different hospitality roles, all sorts. And I guess I didn't really think very much ahead. I didn't necessarily know that I had the bandwidth to do much else. I knew that I liked those subjects in school, but I obviously hadn't succeeded in high school. I didn't really know anyone who went to university. Why would I think I would succeed in university when I hadn't succeeded in school? I thought it was just that bit harder. And when I was 23, so being out of school for like 8 years, my great grandmother, who had dementia that we've been caring for, passed away, and my really old dog passed away. And I was in Brisbane working this job I really didn't like. And my mother decided to go back to university. And I had this moment where I was like, I don't have to live in Brisbane anymore. And I realized that the only reason I had been living there is because I hadn't thought about it, because I thought I was stuck there, because I had these commitments. I had these people I had to look after. I had pets. I had an apartment, things like that. And so I quit my job and I packed up all the objects I could fit in my car and drove away. And I moved to Tasmania, which I visited 6 years beforehand and had been totally in love with ever since. I arrive in Hobart, and I guess with my mother's recent achievements in mind and the fact that everyone I met there had given university a go, where coming up in Queensland, it was like the fancy kids went to UQ or QUT, and if they didn't succeed, then that was like they were shunned. Like that was a real disappointment if they decided that university wasn't for them. It was like, oh, it was because you weren't smart enough or something. Whereas at UTAS, it's the only university on the island, and it's really well integrated in the community. And so it was like everyone I met there gave university a go. And if they decided that it wasn't for them, then it wasn't for them. It was like you would try any other thing, and there wasn't any bad connotations to that. So I was like, oh, what the heck? Like it's going to take a certain amount of time to get my licenses in liquor and gaming transferred over in Tasmania. Might as well give this university thing a go. I went and joined the Pathways program, which is what they make you do if you didn't finish high school, to just check that you can, I don't know, write basic English, do basic math. And the staff there were utterly amazing and were truly invested in your success and just totally inspired me about university as a whole. They let me finish the program in 6 out of the 12 months you were supposed to do it. And then I got like 3 weeks warning before the start of second semester 2016 that I would be allowed to start a bachelor. What do you want to do? And I had the course booklet that I'd had for 6 months at that point when I'd been studying, and I'd highlighted like half the courses in it because I thought that anything under STEM was so cool. I had no idea. I didn't know anything about what any of these courses were like. I didn't know anyone who had done any of those. I had no idea. But my younger brother, who was 9 years younger than me, who likewise had always had a lot of trouble in school, had just started showing interest in computing and video games. And I thought, well, if I have to pick anything, I might as well pick that, because then once I've done it, I can help him do it. So I'll go do that. And I picked computing, having never written a line of code in my life. It turns out that I've loved every moment since. It is totally my life passion, to the point that like you become a nutter about it, where you think that the only people who don't think it's interesting it's because they don't know about it and you just haven't explained it enough. But and thank goodness I liked it, because it turns out my brother then a few years later tried that degree and dropped out after a semester because he hates it. He does microbiology now. He thought it was the most boring thing in the world. So yeah, lucky I like computers. That's how I did that, as a series of happy accidents.
That's fantastic. So, but you're now studying a PhD.
Yes. I mean, some people would say it's just like trying to hide in university forever rather than going out and facing the real world. But also, in other ways, having a PhD is like a membership card to a certain sector that you can't get into without it. It's a nice way to be well respected in a certain fields. It's a nice way to be paid however little for a few years to just do something that really interests you. It's got a real collegiate feel. And I think that at UTAS especially, like I just get to live somewhere beautiful and work out of a cafe or a nice office by the water every day and work on fun computer problems about space as my job. Like that's so silly to me that that's a whole job. Like it's hard work, but it's still it's so creative and so passion driven to me that I can't believe someone pays me to do it. It's awesome. And I mean, I guess after I finish a PhD, then I probably have no more hiding in university to do unless I'm going to work there. I hope I feel ready to leave, because it's my place. I love UTAS.
That's awesome. That was the most amazing story. That was fantastic. I obviously bits of it would not have felt fantastic at the time, but I like the combination of like you thought about stuff, but some of those things were also kind of quite random, and making a
Hot
course
mess.
decision. Hot mess, but yeah, like making a course decision based on someone else's passion is
Yeah, I think
like
that once
that's
you get to a point in seniority in your career, not to say I'm senior in my career, but I have definitely become a person who goes and speaks at events and careers days and stuff. And like I've been put in a position where I was presented like a role model for people, and I like to be very open about that. Like sometimes somebody has ended up in a good place in life, not because they were really smart and did a really good job, but just because they were lucky and they had lots of support. And I am a product of that. I also like what I do, and I've also worked very hard, but to not acknowledge the fact that it's also kind of blind, dumb luck and really good people who invested a lot in me, it could be silly. It's a misrepresentation.
I think the staff at that Pathways program deserve a high five because
Absolutely.
that's amazing. Yeah. And finishing high school is just not for everybody. Yeah, it's very cool. Is there any advice that you would like to give young Mars?
Oh gosh. I was at a conference this week and I was on a panel about student agency and about how you make learners feel in control of their experience of learning, mostly in the context of universities, but just in general. And someone came up to me after that when I talked a bit about how COVID, especially, had presented challenges, and about there have been points in my life where I didn't really know what I was doing and what that would lead to. And this person came up to me from this well respected educational institution and very earnestly asked me, "What could we have done better so that you didn't go through what you went through?" And it really made me think, like, I'm happy I went through that. Like, in some ways, like in the university context, especially, like people who come straight out of high school and they go to university because they expected them to, or they think it has inherent value, or everyone around them did. They sometimes don't really know why they're there, and especially tutoring at university, I see a lot of that where people have come and they do a good job because they're told to be there, but nothing will motivate you to do something well quite like wanting to not do what they're doing right now. When you work in a hospitality job that you utterly hate or you're bored out of your mind, and then you decide on your own agency to go to university to try and do something different, you have a specific reason to get there, to be there, to engage, to work towards. I think that's very important. And so when I talk about how it took me a long time to find my place, it's also what makes me respect it and what makes me grateful for it. And I think that had I just stumbled into the same path, maybe I wouldn't have the job satisfaction that I have every day, because I would look at this hot mess and I wouldn't realize all the other things I could be doing and about how this is so much better. So I don't think I tell her anything. You would just leave her to just stumble blindly through her life so that she ends up here. Sorry, young Mars.
Just have exactly the same. Yep, everything. Just keep it the same. I like it. Okay, in that case, what about advice for another other young people who might be interested in this idea of this sort of piecemeal career that's got where you've crafted your own thing out of all the different opportunities that you've sort of curated?
It's
Advice
really
for
scary. We get it a lot in Tasmania, especially because there's a big thing of people that once they get qualified, they leave the island for work. Because there's this perception locally that there aren't many large tech companies. So especially in the tech sector, people graduate and then they leave. And there's this big hype around entrepreneurship that everyone's like, oh, we just need to equip everyone to be entrepreneurs and they'll make their own jobs here. But it almost goes back around that then we sometimes have this situation where what they're effectively telling these grads are, well, if you're not the kind of person who can make a company out of nothing, then it's your fault that you don't have a job because you didn't make one. And so I would like to acknowledge that having a very piecemeal job or freelancing or being entrepreneurial or having that kind of semi-chaotic life isn't for anyone. It isn't for everyone, and that you shouldn't feel bad if it's not for you. But also at the same time, I would have previously said that would be not for me at all. I liked very rigid structure. I was, gravitated towards jobs that were very clearly delineated. They had very clear expectations. Anything less than that, I would just stress myself to pieces, worrying that I wasn't doing the right thing because I didn't understand what I was supposed to be doing. And I think that the way that people end up in jobs like I have that are very piecemeal is from a progression of self-confidence. Like if I enjoyed something and I did it and I did it well, then I got more opportunities doing that. And I think that at a certain point I realized that if I kept having these jobs appear and I accepted them, then I got more of them. That means I must have done a good job. And I got the confidence to start doing things that I hadn't before, or to be, very client facing and be very honest with those people. Like, oh yeah, this isn't the kind of stuff I've done before, but I'll give it a go. Last year I got a job with a not-for-profit to make a Minecraft world that would be deployed in schools all around Australia. And so they use it now in grade 6 to teach geosciences. It's about how to mitigate against the fallout of natural disasters in like regional communities. And so when somebody comes out of the blue and is like, "How you reckon you can make a professional Minecraft map as a job?" And I'm like, "Well, I guess I've played Minecraft, like I know what that is, but all right, yeah, I'll give it a go." Like if you're just very honest with like, these are my skills and these are all the other projects that I've worked on, they're not really the same thing, but I can demonstrate that I can work it out and I'm telling you that I will work it out. Is that good for you? Sure. So I think that in some ways freelancing is a very human approach towards work. It's just you putting a lot of trust in different people all the time and then putting a lot of trust in you. And that's a lot. So it has to come from a foundation of confidence. And if you're not there, you're not there. But you can get there in pieces. At the same time, I think that certain environments are more conducive to that kind of work, and places like Tasmania are that. If there are only a certain amount of people in your community, then you have to look to whoever's there and whatever tools and skills they have and make it work. So you can also put yourself in places which are more conducive to that.
There was a lot of good advice in there. That was really
Thank
good.
you.
There's just because it might not be right for you now, but it could be right for you in the future. And, don't, I think that's a good one always, is don't assume just because you can't do it now doesn't mean you won't be able to do it later. And obviously self-confidence, quite useful.
Absolutely.
Are there any particular myths or misconceptions that you come across that people assume about you, or telescopes or something that you'd like to take this opportunity to bust?
Oh, I guess like if you're from your background in technology, you'd probably have the same one, that you get people who think that technology and programming especially is not creative. I get that a lot, and particularly at the university, I teach programming quite a lot. I really like teaching first year students because they're, I was about to say the really fresh ones. That makes me sound like I'm going to eat them or something. Like, they're the ones that are most at risk of dropping out, and the ones I think that bolstering their confidence can have the greatest impact on their experience at university as a whole. So I really like teaching first year students, and it's fascinating because you get exposed to all these people that have either taught themselves how to program when they're really small, and this is their first time entering formalized learning about programming, or they haven't programmed at all, but they've heard it's a really valuable skill and it's really employable. And it's fascinating to hear what these people come with, these preconceived notions of programming. And I guess it's been enough years since I started that I forget what my first impressions were, but they think that it's dry, that it's rigid, that it's not creative. And that's so weird to me because it's like you get this set of tools, you get this toolbox, and then every day you have to fix different things with that toolbox. It's like if they gave you one small box of tools and you were tasked with fixing any object in the world. You need to fix this washing machine, this car, this sandwich, this church. Like you have that one set of tools. Like that seems inherently creative to me. Like that is creative problem solving. You need to find new ways to fix problems that sometimes, I mean, I would say not anyone has solved before, and that probably sounds like a lot because you're like, oh, we end up solving a lot of the same problems. But I guess in the very specific way that you will have to implement that solution, no one will have done that before. And so you're always winging it. You're always trying and seeing what happens. That you will F around and then find out of a job. And I think that's really creative. And I think that that's also why in my recreation, I go towards things like Minecraft. I think that it's the same thing. If you have a really constrained medium, it forces you to be creative. I think programming is that. Computer science, I guess on all the ads, we see it as, oh, it's a robot. It's some nodes of webs of glowing lights flying through a void. It's really intangible when you're not in technology to understand what technologists do day to day. And when you just see videos of people ticky tacking on a keyboard, it doesn't seem like it's creative, but it is. And it can be really fun. The other thing is also that as much as I love programming, it's not the only thing in technology. And there's actually so many opportunities within technology and within STEM that don't involve programming at all. And some of the most awesome people I know don't work with programming at all. Like one of my fellow PhD students, her name is Meredith Castles, and she's a friggin' badass. She's a Twitch streamer and a STEM communicator. She's a really awesome lady. And she works in looking at how technology impacts things like education and how people respond to different technologies and how that should influence the design of different technologies. There's a whole bunch of research going on at the University of Tasmania about how people need to be enabled by technology to learn in different environments. And those people don't program at all and think about the value that they're offering the world. It's awesome.
Once again, that was fabulous. Yeah, I don't know how you could communicate in that same green text on a black background and the person in the dark hoodie, like that's creative. I don't know how we can sort of promote that other than I'm not sure. But it's true.
More
It's
videos of
so
all the rainbow
yeah.
colored people with their rainbow coding environments that like shoot out rainbows as they're coding. It's really funny when you go to corporate tech conferences, you see that side of tech, those stereotypes reflected of people in suits typing on computers. And then if you go to hacker conferences, you see all the rainbow colored fursuited queers who actually keep the technology world running. I love that dichotomy. It's just like this is what everyone thinks technology is, and this is what technology actually is. And if you lost this sector, it would all stop running tomorrow.
Yeah. I feel like that's something that you don't see so much outside of tech is that how queer it is. Yeah. It'd be nice for the general public to see that a bit as well. Kind of cool. But we do unfortunately have to sort of head towards wrapping up. So is there anything else we haven't touched on that you'd like to share?
I don't want to make it sound like people who follow the typical path of like they went to high school and they went to university and they have a career is bad, because they're not bad. They're not missing anything. But I also think that you want people from takes all strokes. I don't know. Is there anything I want to errata myself on? I love talking about other people's science. I hope I didn't get anything about geodesy wrong. I didn't get to talk about the awesome stuff that they're doing with space weather at the University of Tasmania, but this is also not an advertisement for the University of Tasmania.
So to wrap up, have you got a shout out for us? A virtual high five that all the listeners can give people virtual high fives to.
Oh goodness, I have so many. I adore my office mates. So I work in an office of a business called Secret Lab, which is my husband's game development company that shares the name with a popular gaming chair manufacturer. So we often get phone calls from people who have bought gaming chairs, wondering what their gaming chairs are, even though our Secret Lab is older. But I work in the office of a game development company with my husband and my two best friends who all work there, who kindly let me work there because it's a more pleasant environment than university campus sometimes. We have better internet, and they're awesome. They're the ones that act as rubber duck to my debugging every day and help me scribble all over their wall-sized whiteboard, solving problems, and listen to me ranting about radio telescopes that has nothing to do with their jobs. They are the reason that I function day to day. My awesome mother, who is doing a PhD at the same time as I am at Southern Cross University, looking at how we can better formalize Indigenous and natural healing knowledge and apply those things in clinical trials to learn about why things like natural remedies and traditional remedies work, like what compounds are in them. And also she looks at so if a pharmacist goes and finds a plant and then isolates a particular compound out of it and puts that in a pharmaceutical, but we identified that plant because people used to eat that plant to cure that thing. It doesn't mean that single compound is what cured people. Sometimes it's a combination of things in plants or whatever fungi, whatever they extracted this from. And she looks at whole compounds, non-isolated compounds for medicine, particularly targeting novel antibiotics, which, if you know anything about antibiotic resistance, is really depressing. So between me working with space junk and her working with antibiotic resistance, we just have these incredibly depressing dinner time conversations whenever we visit each other. But she's awesome. She was a single 16-year-old mom who had me. So she's just kicked ass at every point. She's an incredible lady. I had great support at the University of Tasmania from Paula Johnson, who was the lead of the university preparatory program that I entered in when I was first there, to all of the badass ladies who run the School of Information Communication Technologies at UTAS, including there was this really awesome lady, Nicole Herbert, who was the degree coordinator when I first started there, who didn't have a PhD, which, if you know anything about universities, don't like that anymore. It used to be when someone was a technical college, then you could have staff members that didn't have PhDs. If they had industry experience of a sufficient level, they would come and they would teach, but they wouldn't be proper teachers. And I guess she was a remnant from that kind of time. And she was so good at her job, they couldn't get rid of her. And so every couple of years, these orders would come down from on high of like, oh, everyone should really have a PhD now. Oh, but Nicole, you're fine. Because they couldn't make anyone else a degree coordinator. She was just this like mum for the whole school who would like she could take one look at you in a day, tell if you were doing poorly, and she would know exactly what you needed to get your education back on track. She was just this student support powerhouse. Now we've got Erin Rohrer, the new degree coordinator at School of ICT. We've got, the head game developer at ICT is this awesome woman, Christy DeSalis, and her partner Ian Lewis. They help students there get game dev jobs in industry, even from all the way down Tasmania, where we don't have much industry of our own. The office ladies at UTAS who help you have a gossip on a day where you're just like really sick of work. Just everyone. It takes a village. And one thing that I really like about Hobart is it has been a village for me. And it's kind of that found family narrative because I grew up in Logan, home of the Logan Bogans, and that never felt like home. And Hobart does to me. So everyone there, everyone who's had anything to do with me all the time. My coffee shop owners, my friends, everyone.
Okay, that's a lot of high fives. So we might need to start now. But yes, definitely, especially to your office mates, husband, and the coffee shop owners. I think that's cannot be understated how important that is. So high five to them. I think your mum should come on the podcast because she sounds cool.
She's super cool.
And yes, to everyone at UTAS who's looking up to you and looking up to everyone who finds themselves down there. Yeah. Lots of high fives. I love it. Fantastic.
There's no limit. You give it to everyone.
Everyone gets a high five. No. Fantastic. Well, with that, we should probably wrap up. So thank you so much for coming on the show, Mars. This has been absolutely fascinating. We've covered a lot of ground and hopefully people are feeling, curious and a bit optimistic.
Thank you so much for having me. It was great to chat.